What's up, guys, and welcome to the video on absolute value. All right, let's do it. First, let's start with what does it mean to take the absolute value of something? Taking the absolute value of something, you want to think about it almost like a purifier. All you're doing is you're stripping away any negatives, if there are negatives, and if there aren't, there's nothing to do. You keep it the same. So for example, if we're trying to take the absolute value of 3, a positive number, it's just simply 3. There's no change. But if we take the absolute value of -3, now it's a negative number coming into the purifier, and it is now coming out as +3. Let's quickly talk about the graph of an absolute value function. Okay, so when we're thinking about absolute value functions and the graphs of these functions, just first remember, if you're taking the absolute value of something, you're never going to go negative, right? Whatever you put in, it's always going to come out purified and positive. So this is what the graph of an absolute value function looks like. It's a V. Now notice what happens. This is y equals the absolute value of x. Now, what's interesting to notice is that the y value never goes negative. It's always positive because it is the result of this absolute value function. So even if we put negative values in for x, we're still getting out a positive y. Now, another thing to notice is that when x is positive, this simply looks like the function y equals x. It's the same thing. But once we go negative, it switches, right? Because y equals x would otherwise continue down to negative values of y, but because we're putting the absolute value, it's now going into the positive. It's kind of like the mirror reflection over the y-axis. So right where we have x equals -1, our y equals +1. Where x equals -2, our y equals -2. Next, we're going to talk about solving absolute value problems. Okay, so let's take the simple example of, let's say we have absolute value of x equals +3. All right, here's the process. Every time you see an absolute value function and you need to solve it, first, we're going to split it into 2 different functions. The first way we're going to split it is we just take off the absolute value and we say x equals whatever is on the right side. So in this case, we have x equals 3. Now we take a separate function, we strip off again the absolute value symbols, and we say x equals, and then whatever is on the other side of the equation, we make it negative. X equals -3. And this is the process every time, and it makes sense because if we plugged in -3 into the function, right, we'd bring it through the absolute values and it would come out as +3, and we would have 3 equals 3, and that makes sense. If we plug in a +3, of course, that through the absolute value would also give us 3. Okay, now let's take a little bit more of a complex example. So we're going to say the absolute value of x plus 3 equals 4. So we're going to follow the same steps. We're going to split this into 2 different equations. So on one side, we're going to take away the absolute value and just leave it as is. X plus 3 equals 4. And on the other side, we're going to take away the absolute values, but we're going to take the negative of whatever's on the right side. So x plus 3 equals -4. And now we just solve these 2 equations. So on the left, we're going to subtract 3 from both sides and we get x equals 1. On the right side, we're going to subtract 3 from both sides, but we get x equals -7. And both of these values are solutions. They're both correct. So the absolute value problems will have, absolute value equalities will have 2 solutions. Now let's talk about solving absolute value inequalities. It's a very similar process with a little bit of a nuance. So let's go through it. We're going to use the same example. We have x, the absolute value of x plus 3 is less than 4. Okay, so we follow this first step is the same. We're going to split this into 2 equations. So the first one, we take off the absolute value and we leave the right side alone. X plus 3 is less than 4. But on the other side, we're doing 2 things. We are making whatever's on the right side negative, and we're flipping the inequality. So now it's x plus 3 is greater than -4. So remember, that's very important. You got to make it negative and switch the inequality. So now let's solve both of these guys, we're going to subtract 3 from both sides for both equations, and we get x is less than 1 and x is greater than -7. And now we can combine both of those answers into one equality where x has to be basically in between -7 and 1. Finally, we're going to talk about whether or not we use and or when we are presenting the solution to an absolute value inequality problem. Okay, because we're always going to have two ranges, right? Like in the last example, we had x is greater than -7 and x is less than 1. So is this a case where we are saying it's this and this, or it's this or this? And I'm going to talk about the distinction in a second. So basically, let's go back to the last example. We have x plus 3, absolute value of x plus 3 is less than 4. So this ends up being x is less than 1, x is greater than -7, and we're ANDing the two, okay? We are ANDing them, which means when we say AND versus OR, it means our solution set has to satisfy both of these conditions, meaning a value of, let's say, -8, okay? A value of -8 would satisfy the x is less than 1 condition, but it doesn't satisfy the x is greater than -7, so it doesn't work. It has to satisfy both. So an example that would satisfy both would be x is -3. -3 is greater than -7 and less than 1. And then we sketch something like this as follows, right? We have our circles at 1 and -7, and our solution set is everything in between. And the way that we know that this is going to be an AND versus an OR is in the original equation, we have whatever's in the absolute value is less than another value. So whenever we have it being less than something, it's going to be AND. Now let's talk about OR. So when is it going to be OR? It's going to be in the reverse situation where we have the absolute value of x plus 3 is greater than 4. Right off the bat, we see greater than, we know it's going to be an OR solution. So this would give us the same result, except for it's now, everything is flipped and it's an OR value. So we have x is greater than 1 or x is less than -7, and it's because again of that greater than sign. And if we sketch this out, right, now again we have the circles at the same spots at 1 and -7, but the range of acceptable values, they don't overlap, they go in opposite directions. So it's actually impossible to find a number that satisfies both of these conditions. So a number like 4 would work, and a number like -9 would work, and so on and so forth. All right, guys, that's it for absolute value and absolute value functions. Let's get into some practice problems.